Today we are doing our Godot C++ maze tutorial, and we're actually building our maze. We need both Godot and Visual Studio open. We're going to toggle back and forth between them sometimes. But we are going to put the walls inside of our little box. We last had done changing the size of the maze. And it's still running, so let's get to work in Visual Studio. We're going to add a couple new files. We want maze.gen, let's call it. And that's just going to be a C++ file, not a Godot class. And then we want the Godot class, let's call it mazeholder. We want headers for both of these. So maze.gen and mazeholder. All right, let's start with maze.gen, the just C++ class that's not accessed directly from Godot. We're going to if guard it. And then we are going to pound include random and pound include stdlib. Our maze generation algorithm is going to be pretty dumb, but you'll get the idea. So our class maze.gen, private variables, we want maze width and maze height. We want a two-dimensional bool array, maze data. And then std_mt19937, thank goodness for autocomplete. That is our random number generation. And then our constructor will take in a width, a height, and a uint32t for our random number seed. We're going to initialize that to 0 if it's not specified. And then our destructor. And we want a void generate maze function and a void initialize random 32 that takes in a uint32t seed. And then we want a bool that tells us if a certain row and column is a wall. So bool is wall, and it takes in column and row. And then let's put width and height, the actual words, so that autocomplete looks better. And let's go to the C++ file. Pound include our header. And start with our constructor. So width, height, and seed. And then we're going to initialize random 32 with that seed. And then we are going to set our maze width and maze height to W and H that came in from the constructor. And then we want maze data to be a new bool array. So we are just doing a for loop to fill out the bool arrays. And then inside of our inner while loop, if xmod2 and ymod2 are both 0, then we want our maze data xy to be initialized to false. Otherwise, we want it initialized to be true. And so most of it is going to be walls, but a few areas we know for a fact have to be accessible. And so we're setting them to not be walls. Our destructor, I don't think we need anything. Our initialize random32 function, we take in a seed, and now that I'm thinking about it, we do need a destructor. We just created all that maze data, so let's tear it back down. So if we have maze data, it's not null, then we want a for loop going through to maze width and deleting the inner array. And then we want to delete the outer array and set it to null. So back to our initialize random32. If the seed is 0, then we want an actual random seed. So std random device, and we'll just call it rd, and then seed equals rd. And then we want to seed our RNG with our seed, which may or may not have been set to random device. Now let's do bool isWall. So we just return maze data xy. And then our generate maze function. Let's make sure that this is building, because everything has been declared now. All right, now let's fill in generate maze. So for int column from 0 to maze width, we're going to increment by 2. So column plus equals 2. And then we're going to do a for loop of row from 0 to maze height, row plus equals 2. And then if our row is maze height -1 and our column is maze width -1, that means we're in the bottom corner, and so we're going to leave this square alone, because if we remove a wall, then we will break the outer wall and be able to leave the entire maze. So leave this one alone. Otherwise, if the row is maze height -1, then it is our bottom row. So we want to force column +1 to be open. And then if our column is maze width -1, then it is the eastmost column. So we're going to force row +1 to be open. Otherwise, we are going to do a random, whether it is the row or column that we're going to open up. So on one, we set the column, and on the other, we set the row. Doesn't matter which, because it's random. And that should be it. This is just a quick binary tree type maze generation, so it's going to have a very simple solution, you'll see. You can always walk down or to the right, but it proves the point, and you can come up with much better ones. So we're going to switch over to maze holder now, and let's if guard the header. And then pound include a bunch of Godot stuff, core Godot, node 2D, because that's what we are. Resource, because we're going to load a resource loader. And we need to pound include core ref. And we also need to pound include packed scene, because that's what we wind up getting when we load a resource from disk. And then we also need to pound include our root.h and mazegen.h from our project. We are in namespace Godot. Our class is mazeholder, and we are type public Godot script. And node 2D. And then our macro Godot class, mazeholder. And then for private, we want our maze generator pointer. So we'll call that pmaze. And then we want a node 2D two-dimensional array of pointers to node 2Ds. So that is going to be our maze nodes, which are going to be the wall nodes. And then we want a Godot ref to a Godot packed scene, and that's our wall scene. And then we want a maze width and maze height. They can be int. And then for public, we need our static void register methods, of course. We are going to use our ready function, so void ready. And then we need mazeholder and tilde mazeholder, our constructor and destructor. And we need a function add walls to maze. We'll just do void add walls to maze. In our C++ file, let's pound include our header. And then using namespace Godot, and then we can do our register methods. So we're going to register method our ready function, and I believe that's all that we have. Mazeholder ready. And we also want to register the class. So let's do that quick. This is in Godot library.cpp. So register class Godot mazeholder, and that's it. Just add it inside of native script init. And then of course we need to include the header, which is why it was showing me an error. All right, so back to mazeholder. Our constructor, we are going to load our wall scene. So wall scene equals resource loader, load. And then we are pointing it to our base directory of resources, and the name of it is wall.tscn. And then mazeholder destructor, we are going to delete pmaze because we are going to be the ones that create it. And we're also going to have all those nodes. So maze nodes, if we have maze nodes, then let's walk through them. So for int x equals 0 to maze width, we will delete maze nodes x. And then let's just delete maze nodes and set it to null. And then our ready function, we want to get our maze width from root maze dimensions, which should be set. And we're going to grab it and subtract 2 because the maze dimensions have the walls, the outer walls, but we're creating an inner maze and not the outer walls. So subtract out the outer walls in each direction. So we've set our maze width and height to root's maze dimensions. And then let's create a new maze gen object for, we are going to put a seed of 1 so that we can debug easier. This is so that the same maze gets generated every single time. And then we want to generate the maze. And we want to set up our maze nodes. So we're creating a new array of node 2D pointers. And for int x 0 to maze width, maze node sub x is a new node 2D pointer array of maze height size. And then at the end of this ready function, we want to add walls to maze. So now let's proceed on to our add walls to maze function. So at this point, our maze nodes have been allocated, and we just need, well, our pointers have been allocated, and then we just need to instance in the walls and put them in. So for int x equals 0 to maze width, for y equals 0 to maze height, if our maze has a wall at x comma y, so pmaze is wall xy, then we want a name. We're going to need a name for this wall that we are instancing. So sprintf wall %d underscore %d. We'll just do that for our name. And let's do a node 2D. So we're going to create a node 2D pointer n and just set that to maze nodes x, y, which is being set to wall scene instance. So we are creating an instance of the wall scene and assigning that to our maze nodes array, and we're also grabbing a quick pointer to it so that we can do set name very quickly, and set name name, and then and set position vector 2, x times 128, y times 128, and that's it. And then we want to add a child, and we are done, I believe. So let's build this, and it built correctly. So let's go to Godot and see if we have a maze. Oh, we need to add it. So let's add it to inner walls. And so maze holder. And we never created the file for it. All right, so go to your Godot project directory, make a copy of one of your other gdns files, and rename it maze holder. And then edit that in whatever your preferred editor is. And just swap out player to maze holder in the resource name and class name section. And then now we can go back and let's get it to update. And there we go. We've attached a script. So we should be able to run it. So now look at that. We have a maze inside. And then if we go to main, we do not have our... So if you run into this issue, then you need to restart Godot. So let me do that right now. All right, so restart Godot. And when you restart it, if you go to main, it should have maze dimensions. So there you go. If your script variables ever disappear, you just need to reboot Godot. It doesn't happen very often. I don't know exactly why it happens, but when it does, just reboot Godot until they fix bugs.